Hello students, let's welcome to our YouTube channel Physics for UG. Now in this video we shall discuss about Young's double slit experiment. So normally we have two approaches for interference pattern. The first one is division of wavefront and another is division of amplitudes. So division of wavefront means the wavefront is divided and division of amplitude means the amplitude is divided. So in division of wavefront cases we use Young double slit experiment, Lloyd's mirror, Fresnel biprism, etc. All these are the different approaches for division of wavefront. But in case of division of amplitude cases, the Newton's ring is the very important case, and in Newton's ring we use division of amplitude case. So apart from that, we discuss about Young's double slit experiment, and in this video we shall study about the fringe width, the maxima minima, what is the interference pattern in Young double slit experiment, and what is the path difference between the two waves, and what is the intensity value, maximum minimum value, which I discuss in this video. Let's start one by one. Okay, look at the figure. There is a source S. This is the source of light S. It propagates light with spherical wavefronts. So from this slit S1 is a slit and S2 is another slit. So in the slit the wavefront is divided, that means light passes through this like the wavefront, and from S2 light passes like this in this wavefront. Okay, so what will happen due to interference of these two wavefronts? An interference pattern is obtained on this screen, and this AB and this edge is the screen, and on this screen we get the interference pattern. What kind of pattern we obtain from the screen we shall derive and discuss in this video. Let P be any point at which we want to investigate the intensity. Here this P is the point at which we have to investigate the pattern. We can investigate at everywhere, but for our convenience we choose that point P here, that point P, and that point P is a distance y from the center C. From this is y distance, two rays S1P and S2P starting from S1 and S2 reach P and interfere with each other. This is S1P first ray, S2P, this is the second ray. This is first ray, second ray. Okay, and the two rays interfere at P. So if x is the path difference between the two rays, x equal to S2P minus S1P, because if we draw a perpendicular from S1 to this line up to T, then this length will be extra. This is the extra length. So this is the path difference. So x is the path difference, because this side is equal to that side, so these are the same path, so path difference will 0. So extra part will be this, x is the extra part. So this x equal to S2P minus S1P, this is the path difference. Remember, this is the path difference. Okay, so path difference basically means the difference of path between the two rays. Okay, from this figure S1P square, what will be S1P square? Look at in the figure, this is S1, this is P. S1P square equal to S1D square plus PD square, because S1 S1PD is a right angle triangle. Okay, so in that part H square equal to P square by B square, so S1D square plus PD square. So S1D equal to D square, because this is the slit and this is the screen. So distance between slit and screen is capital D. That will be D square, that will be D square, and y minus dy by 2 whole square. If the full slit separation is small d, then the half will be d by 2, then the half will be d by 2. So from C to P is y, so from D to P will be y minus d by 2. From D to P, because y minus d by 2, and from P to E this is y plus d by 2. Look at the figure. Okay, so what will be s2p square? Similarly s2p square. Similarly for the another right angle triangle, s2e square plus p square, that is d square plus y plus d by 2 square. It is clear from the picture that these two are the right angle triangles, so h square equal to, use the formula h square equal to p square plus b square. So what will be h2p square minus s1p square? Take this one is the h2p square and this one is the s1p square, so take minus. Okay, so this part is the s2p square, d square plus y plus d by 2 square minus d square plus y minus d by 2 square. So from this part, this d square and d square cancelled. The remaining part is y plus d by 2 whole square, y plus d by 2 whole square minus y minus d by 2 whole square. This is similar expression like a plus b whole square minus a minus b whole square, whose formula is equal to 4ab. So we can use directly, that is 4ab. So what is 4ab? That is 4 into what is a, this is y, and this is d by 2. So last part will be 2yd. Look at here, this is right hand part 2yd. This is solved by using the taking the squares of two parts. We get 2yd. So what is the left side part? What about the left side part? This is s2p square, this is s2p square minus s1p square. A square minus b square, that is a minus b into a plus b. Okay, what is a minus b? s2p minus s1p is the x, is the path difference. Look at the fourth line of this page, x. And what is s2p plus s1p? That is 2d, because for the large distance we choose s2p nearly equal to s1p. If this is the slit and this is the screen, if they are placed at a very far distance, very large distance away, then the s1p and s2p will be nearly equal to capital D. We assume it that s1p equal to s2p equal to capital D, that is the distance between the slit and the screen. That is x equal to y into small d by capital D. This is the, remember, this is the path difference between the two rays which are interfering on the screen. Now next part is, what is maxima? Remember, maxima is basically the point where we get a bright spot, or maxima is also known as constructive interference, and minima is also known as the destructive interference. Minima means we get the dark spot and maxima means we get the bright spot. So point P and the interference pattern is to be studied at point P. Okay, point P will be a bright spot if the path difference x is even multiple of lambda by 2. This is the condition for interference. For maxima, the path difference x should be even multiple of lambda by 2. That means with lambda by 2 we have to multiply some even number, that may be 2, that may be 4, that may be 6, that may be 8, whatever, but that should be even number. So what will be the path difference? Path difference is y into small d by capital D. Here this is y into small d capital D, that is equal to even multiple of lambda by 2. Okay, that is y equal to n lambda d by d. What is n? N value is, n can be 0, n is 1, n is 2, n is 3. Okay, by solving this we get y is equal to lambda into capital D by small d. Okay, so if we put n equal to 0, we get y equal to, this y equal to 0. If we put n equal to 1, we get lambda d by d. If we put y equal to 2, we get 2 lambda capital D by small d. If we put n equal to 3, then we get 3 lambda into capital D by small d. So these are the places of a bright spot. These are the distance from C. What is C? C is the distance. This is the center of the two slits. This is C point. This is slit S1. This is S2. This is point C, and this point is P, which is a distance y from the C. So we get bright spot at distances y equal to 0, lambda into capital D with small d, 2 times lambda capital D with small d, 3 lambda capital D with small d, 4 lambda capital D with small d. So these are distances at which we get the bright spot or maxima. Okay, next is discuss about minima. What is minima? Just opposite condition. The point P will be a dark spot or a minima if the path difference x is an odd multiple of lambda by 2. That means the path difference x should be odd multiple. Odd means odd number 2n plus 1 lambda by 2. Odd number means that may be 1, that may be 3, that may be 5, that may be 7, that may be 9. Okay, if lambda by 2 is odd multiple, then we get minima or dark spot. If lambda by 2 is multiplied with an even number, then we get maxima or bright spot. So what will be the this part is our x, means this is the path difference equal to odd multiple of lambda by 2. So we use and we get small y equal to 2n plus 1 lambda into capital D by 2d. What is y? Y the distance from the center of the two slits. Okay, what is the value of n? N equal to 0, n equal to 1, n equal to 2, n equal to 3. If we put n equal to 0 here, if we put n equal to 0, we get 2 into 0 plus 1. That means 1 into lambda into capital D by 2d. This is the first part. This is the first one. This is the second. If we put n equal to 1, we get this. If we put n equal to 0, we get this. If we put n equal to 2, we get this. If we put n equal to 3, we get 7 lambda into capital D by 2d. If we get n equal to 4, we get 9 into lambda capital D by 2d. So what we get? Remember, for the bright spot we get 0, 1 into something, 2 into something, 3 into something, 4 into something. For dark spots, what do we get? 1 by 2 into that something, 3 by 2 into something, 5 by 2 into something, and 7 by 2 into that is the same thing. Okay, so what we get? So first 0 we get bright. Okay, 1 we get bright, and 1 by 2 we get dark, 3 by 2 we get dark, and 2 we get bright, because 3 by 2 is in between 1 and 2, and half is in between 0 and 1. So what we get? There is a bright spot at the center, because y equal to 0. Y equal to 0 means at point C y equal to 0. So at point 0, at point C, we get bright spot, then dark, then bright, then dark, then bright, then dark. So eventually we get alternate bright and dark bands, dark fringes in the interference pattern of Young double slit experiment. So now let's discuss about fringe width. What is fringe width? Fringe width basically the width of the fringe, or in definition, it is the distance between two consecutive bright or dark fringes. Look at the here. This is at the center, at center O. There is a bright fringe, then this is dark, then this is bright, then this is dark, then bright, then dark. So distance between bright and bright and distance between dark and dark is called fringe width. Consecutive, remember, consecutive bright and dark fringes is called fringe width. Bright, bright, so bright and bright, so bright, bright, and dark and dark. So distance between two consecutive bright or dark fringes, it should be or, means or, that is not and. If we use and, that will be completely wrong, because if we use and, then it will give the data of dark and bright. It will give this value, and this will be half of the fringe width. If we use here and then the fringe width, then this part will be half of fringe width. So remember, it is the distance between two consecutive bright or dark fringes. Okay, now xn and xn minus 1 be the distances of nth and n minus 1th bright pins from C. Suppose what is nth and n minus 1 bright pins? This is from the situation at distance n. What will be the bright situation? That is n lambda into capital D by small d. What is n minus 1 part? That is n minus 1 into lambda into capital D by small d. If you minus from one to other, then this is nth order, this is n minus 1th order. So after subtracting, what we get? We get beta equal to lambda into capital D by small d. This is the fringe width formula for bright fringes. Okay, so fringe width beta is directly proportional to lambda. Fringe width beta is proportional to capital D, and fringe width beta proportional to 1 by D. That means if capital D increases, the fringe width increases. That means if the slit and screen separation increases, the fringe width increases. If lambda increases, the fringe width also increases. If small d increases, the fringe width decreases, because if the separation between the slit S1 and S2 it will increase away, then the fringe width will decrease. What is fringe width? Basically, fringe width means the distance between two consecutive bright or dark fringes. Okay, similarly we can prove that two consecutive dark fringes can be separated by same distance, beta prime equal to lambda into capital D by small d, and whether it is dark fringe or bright fringe, the fringe width is always lambda into capital D divided by small d. This is very important formula while solving various problems in Young's double slit experiment. Okay, that means the bright and dark fringes are equally spaced. That means bright, dark. Their spacing have equal spacings. Okay. Now move to the intensity distribution part. How the intensity will be distributed and what will be the intensity of the maxima and intensity of the minima, what is the amplitudes of the two cases. Now let's discuss this part. Let A1 and A2 be the amplitudes of the two waves reaching the point of observation P from S1 and S2 respectively. Okay, so in the figure, if this is S1 and this slit is S2, this is the screen and this is the point P. If the two waves which are reaching at point P, the amplitude of the first wave is A1 and the amplitude of the second wave is A2. Okay, if delta is the phase difference between the two waves, then the net amplitude R at P is given by, this is the formula for amplitude, that is equal to R square equal to, sorry to say that there is some rectification needed, that will be A1 square plus A2 square plus 2 A1 A2 cos delta. What is delta? Delta is the phase difference. From the S1P and S2P there is a path difference x, and every path difference is accompanied by a phase difference, and this is the phase difference delta. Okay, for a good interference pattern, the two waves must have the same amplitudes. Two amplitudes of the two waves will be equal. So we take A1 equal to A2 equal to A. So what will the expression? R square equal to A square plus 2A square cos delta. Remember, this formula is similar to triangle of vector addition. As for triangle of vector addition, R square equal to A square plus B square plus 2AB cos theta. Theta is the angle between A and B. Similar here, delta is the phase difference, or similar to the angle between the phase difference between the two waves. Okay, so look at here, R square equal to A square plus 2A square cos delta. So this part is A square plus 2A square plus 2A square cos delta. So this will be 2A square plus 2A square cos delta. take 2 square as common, 2 square common, so remaining part is 1 plus cos delta. What is 1 plus cos delta? You can use the formula 1 plus cos theta equal to 2 cos square theta by 2. There is your formula 2a square we use, so 2a square into this much, that will be 4 into directly 4 into a square cos square delta by 2. Okay, also you can use this formula, because from this formula, that is cos 2 theta, you use the formula cos 2 theta is equal to 2 cos square theta minus 1. Here we use cos delta, that is equal to 2 cos square delta by 2 minus 1. We use this formula cos delta. Okay, that cos 2 cos square delta by 2 minus 1. So answer will be r square equal to 4a square cos square delta by 2. What is delta? Delta is the, remember, delta is the path difference, sorry, delta is the phase difference between the two. Okay, another part. Since intensity is proportional to the square of the amplitude, always intensity is proportional to amplitude square. So I equal to k r square. K is the constant of proportionality, so I equal to k into 4a square cos square delta by 2. What is I? I is the intensity which is proportional to the square of the amplitudes. I equal to k r square. So this one is r square, this one is k. So I equal to k r square cos square delta by 2. So how can you check for maxima and minima? Okay, remember this I as k into 4a square cos square delta by, this I the intensity. So first check the maxima condition. So for maxima, cos delta by 2 should be plus minus 1, because cos square delta by 2 should plus minus 1, and cos value of n pi, so delta equal to 2n pi. So from this part, maximum, for maximum value of cos square delta by 2, this value should be plus minus, this value should be plus 1. Okay, so the answer, what is the I max? Equal to 4 into k a square, because k into 4 a square, that is 4 into k a square. We put cos delta by 2 equal to 1. Okay, that is equal to 4i. What is I? I is the, this small I is the intensity of the individual waves, because I proportional to a1 square and I proportional to a2 square, because a1 equal to a2, that's why we use I proportional to a square. What is I? I is the amplitude of the single slit wave, single, S1 S2 are two slits. So for a single slit, I is the intensity. So I max equal to 4 into k square, that is 4i. Okay, I the intensity at any point due to a single source. Next is minima. So what is for minima? What will be cos delta by 2? Cos minimum value will be 0. So intensity will be, definitely intensity will be 0. That is I minimum, intensity will be 0. So what are the patterns? Look at here, what are the patterns? I minimum equal to 0. I minimum, this I minimum equal to 0. So this, look at the figure, this is the interference pattern. So at the center 0, center O, this point has a maxima. For the intensity, that is 4k a square. We have already find out that 4k a square. And for the second, that at pi, this is minima 0. For maxima, this is also 4k square. This is minima, this is at 3 pi, this is also 0. Maxima at 4 pi, minima at 5 pi, maxima at 6 pi, minima at 7 pi. Remember there one thing, the center part, the center O is called the center O is called central bright. Okay, the first is called the first dark. At pi point, this is called first dark. 3 pi second dark, 5 pi third dark, 7 pi fourth dark. First, second, third, fourth dark. Similarly, this point at point 0, this is the central bright, this is the first bright, this is the second bright, this is the third bright. So also same is the opposite side. This is the first bright, this is the second bright, this is the third bright, and this point are the dark points. So easily you can understand and you can get the situations of interference pattern which is created due to the double slit experiment, Young double slit experiment. Okay, thank you. If you like this video, then share the channel, subscribe the channel, and like the video. Thank you.